Queens and kings of physical computing, it's Prof. Gene. In this lesson, we'll take the Raspberry Pi Pico for a spin using a potentiometer. A potentiometer is an analog input device, usually a knob, but there are other kinds as well. In a prior lesson, we used this knob-style potentiometer with the Circuit Playground Bluefruit. We'll now hook this bad boy up to a Raspberry Pi Pico. And in case you have one of these far more common, inexpensive plastic potentiometers, you'll often find these in intro electronics kits. I'll show you how you can use one of these as well. The concepts are very similar. Now we'll first show how to use CircuitPython to read values from the potentiometer, and then we'll have a challenge and show the solution to turn the individual LEDs in our light strip on or off based on readings from the potentiometer. And even if you complete the challenge, you should stick around and check out the solution I'll demonstrate, because I'll also show how you can use the Python concept of slices to quickly update LED lights on a strip without having to use any for loops at all. Let's spin up some big learning. So my students have one of these potentiometers that's on a breakout board, and they also have this 3-pin JST cable for breadboard hookup, but you can hook up one of these inexpensive plastic potentiometers common in many intro electronic kits too. All you'll need is 3 jumper wires. I'll show you how to do that in just a bit. Now these 2 potentiometers have knobs, but there are lots of other kinds of potentiometers as well. For example, my students also have 3 slider potentiometers. They're also connected via the same 3-wire setup, power, ground, and signal. We'll use those in a future lesson. Now here are the wiring diagrams for either of the knob potentiometers I just showed. Anytime you use a potentiometer, you've got 3 wires, power, signal, and ground. This potentiometer has 3 pins labeled SVG, that's for signal, V is for voltage or power, and G is for ground. And you also see these arrows to show how to turn for a minimum value or a maximum value. And when choosing a signal pin, make absolutely sure that you're choosing a pin that supports analog input. On the Pico boards, the analog pins are GP26 through GP28. You can also refer to them by the names A0 through A2. For power, make sure that you use the 3.3V out pin. The other pins will provide more power, and that's going to result in inaccurate readings at the high end of the scale. And here's a quick look at how things are set up with one of these inexpensive plastic potentiometers. Now if I take this off of the breadboard, you see that there are 3 legs. The left one is what I attach to ground, the middle to signal, the right to power. Now that middle pin is sometimes called the wiper pin because what's going on inside the knob is it wipes or slides along a track. Its position on that track indicates the voltage that's allowed through the circuit, and this allows the potentiometer to read different values as that knob is turned. By the way, here's something you can try on your own. On these types of potentiometers, the middle pin is always the signal pin, but if you flip the ground and the power wires, you'll get readings in the opposite direction. So the location on the dial that used to be high is now low, and vice versa. And here's the setup of the potentiometer breakout board. The jumper wires are heading into the same locations on the breadboard, but note the key difference. The signal wire labeled S is on the far left. It's not in the middle in this configuration, so make sure you wire it up right. And again, you can use any of those 3 analog pins for your signal. Just make sure that your power goes into 3.3 volt. Now to code things up, this is familiar to you if you went through the earlier lesson on potentiometers using the Circuit Playground. We import analog in from analog I/O, then we create an analog in object. I'm calling mine potentiometer, a good name for a potentiometer. Mine is connected to pin A0, which is the same as pin GP26 on the Pico. You can use either name if you'd like. And then down here, we'll simply put the reading returned from the potentiometer's value property into a print statement so we can see the potentiometer reading printed to the console. And I'll add a 1/4 second time sleep delay just so that the speed of the board output doesn't overwhelm the slower printing. So let's code. I'll start with a comment, pico-potentiometer.py. We'll import from board and time, and also from analog I/O, we'll import analog in. Then we'll create our analog in object. We're going to call that potentiometer, setting that equal to capital A analog, capital I in. I'll pass in board.A0 since that's where my signal pin is attached to. I could have also called this board.GP26. Either name would work. Some pins have multiple names, sort of like some wrappers. And before while true, I'll say print, passing in potentiometer code is running. And then in while true, we'll print potentiometer.value. And just to make sure that we can see this output, we'll time.sleep, and in parentheses, we'll pass in 0.25 to wait a 1/4 second. Open the terminal, run TO, save. And look at this, as I turn things, I start off and I'm down at the low end of the potentiometer knob, but as I turn clockwise, I can see the numbers are getting larger and larger until I'm up around 65,000. I can go back down, I can move this in both directions. My potentiometer readings are working fine. Another scale down, good work. Now let's save this to our CircuitPython school folder as pico-potentiometer.py, and make sure you close that external tab. Now it's time for a challenge. Now the challenge is going to use a potentiometer and a NeoPixel strip, so I'll keep the potentiometer wiring the same, and I'll wire the NeoPixel strip to V-bus power with the signal to GP16. That's this pin here in the lower left. So in this challenge, you'll modify your code so that as you turn the potentiometer, you light up the LEDs on your NeoPixel light strip. So turn to the far left counterclockwise and you shouldn't see any lights. Turn to the far right or clockwise and you should see all of the lights light up. And you should progressively turn the lights on or off as you rotate the potentiometer knob in either direction. The video on the right is showing you how things should look when things are done. So why don't you give this a shot? Pause. I know you can do it. And when you're ready, resume, and we'll compare answers. So let's start by changing the comment up top to read Pico Potentiometer Rolling Lights. For those of you that use the Circuit Playground lessons, we used a similar name when tackling a similar problem with that board. And I'm going to set up a few variables to hold key values. So right underneath where we set up our potentiometer, I'm going to say max reading equals 65,535. Remember, our potentiometers read from 0 to 65,535. And oh yeah, let's not forget, we've also got to import NeoPixel up here to make sure that we have our NeoPixel library. Then below max reading, I'll create another variable, num of lights, and set this equal to 30 because there are 30 NeoPixels on my NeoPixel strip. Then under that, I'll create a value called number of options, setting this equal to num of lights plus 1. What does this mean? These are the number of options I want to read by moving my potentiometer from all the way to the left to all the way to the right. I want 1 for each light, so there are 30 lights. That should be 1 through 30. But I also want to be able to turn off all the lights, so that's 1 more, so there should be 31. So that's an important distinction. If you always wanted at least 1 light on, you'd only have 30 in here, num of lights. But if you want that additional option of shutting off all the lights, you need to add 1 more, so you get 31 options. Then we'll set up our NeoPixel object. We'll call this strip, and we'll set this equal to NeoPixel.NeoPixel, capital N, capital P, and in between parens, our signal pin is connected to board.gp16, comma, num of lights is the number of lights, that's 30, comma, and let's set brightness equal to 0.5. Lowering brightness usually isn't an issue with the Pico boards in the way that it is with the Circuit Playground boards, but I'll do this just in case. Then we'll create colors, all caps blue equals in paren 0, 0, 255, and all caps black equals in paren 0, 0, 0. And I'll modify our print statement before while true to read potentiometer with NeoPixel's code is running, and I'll delete what's inside the while true. And why don't we grab our potentiometer value reading, putting it in a variable reading equals potentiometer.value. And next, let's figure out how many lights we need to turn on. Now again, basic middle school algebra here, but what you want to do is think about how we can get a value from 0 to 30. 0 means no lights, 30 means all the lights. So what we'll do is we'll say lights underscore on, that'll hold the number of lights we want to turn on, 0 to 30, and we'll set this equal to our reading multiplied by, and this next part is a calculation, so we'll put this in parentheses, the number of options, remember that's going to be 31, divided by our max reading. Now we're not quite there yet. What we want to do in our math is make sure we never reach the whole number 31. Now there are a bunch of ways we can do this. There are conditional statements we could use. Some folks might use min-max techniques, but if we say lights on and we reach 31, we're going to be in trouble. Now we would get that if our reading was 65,535 and our max reading was 65,535. So the technique I'm going to use to make sure that we never hit that max reading is I'm going to say max reading plus 1. And note that I put that inside of parentheses. That's important because I want to add 1 to max reading before I use it in any other parts of the equation. Now this will give us a nice decimal number which we'll go up to, but it'll never reach 31. Now we know from earlier lessons that we can't use a decimal number when we want to light up a certain number of lights. A decimal is not a light index. You can't get a fractional light. Well, there are a few ways that we could turn that fraction into a whole number. One way is we could round, but round would round up, and we don't want to do that. What we'll do instead is we'll convert this to an int, an integer, and what that's going to do is it's going to drop all of the decimal points, just use the whole number part. So in PyCharm, I can highlight my entire equation, I can type a left parenthesis, the right parenthesis goes on the other side of the equation, and I'll put lowercase int in front of this. So if you think through the math on this, you'll always get a number from 0 to 30, nothing larger. And I'll put a comment after this that says, must be a whole number, int rounds down, max reading plus 1 ensures we'll never reach 31. Nice! And then down below, just to make sure that we're getting the values that we expect, I'm going to say print between parens. This is going to be an f string, so lowercase f, and in between double quotes, I'll say lights to turn on, colon, and in between curlies, I'll say lights on, comma, reading colon, in between curlies, reading. Now in the next line, I'm going to create my first slice, and this is going to be the slice that turns all of the lights that I want to turn on blue. And the way that I'm going to do this is I'm going to say strip, the name of our NeoPixel strip, and in between square brackets, I'm going to use a slice. And I'm not going to put in anything for the first value. I'm going to say colon. Now remember, when you have nothing in the first value, you say start at the first value. So for us, that's index 0. And then after the colon, I'm going to say lights underscore on. So that means I'm going to light up all of the lights from 0, the beginning, all the way through, but never reach lights on. So that turns on the lights from 0 through lights on -1, which is exactly what I want, because remember, our lights are 0 indexed. Want to turn on the first 5 lights? You've got to turn on lights indexed 0 through 4. Cool. Then we need to make sure that we're passing in the right number of blue lights, and the way that we'll do this is we'll just say equals all caps blue times lights underscore on. And in a comment, I'll remind you, turns on 0 through lights on -1. That's lights on number of lights. Then in the next line, super simple. We just say strip, and in between the square brackets, we'll say lights on, so we're starting one light after where we stopped, because remember above we stopped at lights underscore on -1. That's the way slices work. And by saying colon with nothing after it, we say go right through the end. What are we going to set this equal to? Black multiplied by, in between parentheses, num of lights minus lights on. That's the remaining number of lights. Drop a comment in here, turns off from lights on through the end, and then we'll add a time.sleep at 0.05 just to slow things down a smidge. You don't need that, but it'll help us read out our print statements. Then let's open up the terminal, get into TO, save our work, and ho-ho! Serial console shows no lights. Let's turn that knob to the right. And ding dang, look at that. Lights going on, lights going off as you turn it in different directions. Let's crank it all the way up. Fabamundo. No crashes when we're at the maximum for our potentiometer, and you can scroll back and forth. This is looking spectacular. You have a potentiometer working on a Raspberry Pi Pico with a NeoPixel strip using slices. That's some pretty advanced work, Pythonista. Nice going. Let's make sure we save this masterpiece to our CircuitPython school folder, and make sure you close the outermost tab. But feel good about your sparkling, spinning, utter coding dominance. Do me a solid thumbs up, like, drop a comment, because I'm always at work producing more goodness for you. Continue to hack.